Good morning. Welcome to our box culvert webinar for the American Concrete Pipe Association. This will be specifying, approving design and coordinating construction. We have two presenters today. Both of them are from the Utah area, Jason Allen and Randy Wallen. And we'll give everybody just a couple minutes to continue logging on and getting set up for the call. And while we're waiting on that, I'll just explain the panel that you should see. If it's in your way, you should see an arrow on the upper left-hand corner that you can push, and it'll hide the control panel and get it out of your way so you can see the presentation. Everyone is on mute, and so if you have a question, you'll see a question panel. You're welcome to type any questions in there. We'll try and ask them at the end of the presentation, or if they're really pertinent to an exact slide that is being discussed. I can interrupt the presenters and ask those questions as well. So it is now 2 after, so to be respectful of everyone's time, I'll go ahead and turn it over to Randy. Randy, you want to get started?
Well, welcome everyone. Hey, we're excited to be here. We've got about 320 people logged in so far, and we have, I think, another 200 registered. So we're excited to have this many people here. We think we've got a great presentation for you today, and we think you'll be pleased. And so we'll just jump right in. My name's Randy Wallen. I'm with Oldcastle Infrastructure. I've got 31 years of experience. This is a photo of me, so you kind of know who you're looking at. It's a lot better than what you would see on a webcam right now. So I think that's true with Jason too. So my experience goes back to, I worked for local DOT, city, consulting, but I've been in the concrete pipe industry for 20 years.
And my name is Jason Allen. I have 17 years of experience as a civil engineer. I've worked in both the private side in private consulting and in the public side as a county engineer. And I've been in the concrete industry for 3 years now. I'm currently the executive director of the Mountain States Concrete Pipe Association that covers Utah and Idaho. So we're definitely happy to be here with you.
Thanks, Jason. So starting out, we have a certificate for PDHs that we'll be sending out today to all those that attend. We wanted to point out that each state may have different requirements. We're not able to vet all those requirements, so that's up to you to think about what's important in your state. We want you to determine that. There may be states that it needs to be pre-approved. I think I've heard of maybe 1 or 2. This is not pre-approved with your state necessarily. So if that's a problem, we apologize, but we wanted to inform you of that straight up. And we want you to participate in the webinar. We'll have some poll questions coming up, and please participate. And so we'll jump off there. We wanted to let you know what.
We actually have a poll question here right off the bat. And
okay.
Before we get to that poll question, I have gotten a question about what if you have a group of folks listening on together. We'll send that PDH certificate out to anyone has signed in, and then that person can distribute it amongst their office. We're working on an honor system here, so if your folks did participate, they're welcome to use that PDH. So let me launch the first poll. The first poll says, have you ever specified a precast box culvert for, the key part here is for the manufacturer to do the design? Yes or no? So go ahead, you should be able to click on that.
And we don't want the manufacturers or associates to answer this, just the consultants and DOTs.
We'll give everybody just a couple more minutes.
And will you read those out, Kim?
Sure thing.
When you get them for me.
Got about 2/3 who have voted. So if you're just logging on, we're asking a poll here. This will be part of your participation for your PDHs. I'm going to go ahead and close that. We got 70% who voted. And here's the results. We have 47% that said yes, 53% said no.
Well, that's great. Thank you for your participation on that. That's, I think, whether you've already specified something in the past or whether this is new to you, I think this will be helpful. So we're going to talk about the correct standards, loads that need to be designed to, but we're going to talk about how that should be done by the local manufacturer's registered engineer. So that's one of the things we're going to talk about today. We're going to talk about how the site civil designer should specify precast concrete box culverts, and we're going to talk about contractor installation and what a key part of the process that is. Now, as we talked about, the best practice that we're recommending is to have the local manufacturer do the design. And one of the reasons is because that manufacturer is going to know what forms are available and what standards are critical to their market. They're going to know what kind of steel that they would use, and we'll talk about this as we go through it. And for someone else to design something that ties the hands of this manufacturer is not always economical, so it's best for the manufacturer to coordinate with the site civil designer. They know their mixed designs, they know how their concrete works and what options they have, and they know the design code. So one of the things that's important in this process is to use a precast plant with an approved QA/QC program. Now, there's different programs out there, and different manufacturers have their own programs. So that's where we'd ask you to coordinate with them and see what is typically done in your state. But that's really important. It's one of the things that is really well done with our product is we're able to do in-house QA/QC. Now, this is a project that happened about 10 years ago, and I'm going to talk about this just in general so you can get a feel for what we're talking about. This was a 3-lane highway, and a city wanted to take and update the box or the piping that went across this road for a canal crossing. And when they came and did this, it was designed originally, and you can see this here, it was designed to go across this 3-lane highway, and they were going to widen that out to a 5-lane section. And when they got their first plans in, they looked like this. And Jason, I'll ask you, what would be the first clue on this that it's not a precast box culvert?
Well, when I look at the detail there that says section through barrel, I notice there's no haunches in that detail.
Right. So this was designed as a cast-in-place box culvert by the consultant, which was fine. And the city came to us and said, "Can you do a 16x9 box or a 16x6 box culvert for this crossing in precast?" And we said, "Sure, we can. That fits what we have in our standard forms." And the city said, "Well, we really want to consider that because of the time savings." And he said, we're concerned that when we go and have to shut down this highway, we don't want to deal with the residents. There's a lot of neighbors out there. This could take a month if it was cast in place and we could be shut down, where how long would it take you to do in precast? And we said, well, you could probably set this in a weekend, which is what they ended up doing. And with that, they were able to open that up to traffic again very quickly. So as they bid this, they found that it was $7,000 more to do a precast box culvert, but they happily did it as they were able to not have to do all the inspection of all the rebar on site. They didn't have to do all the traffic control that may not have been considered. If you consider the cast-in-place design that they did, they probably spent $7,000 doing that, and they also didn't have to worry about all the traffic control, complaints, other things. So this was an example project. Now, 10 years later, they came to us about a month ago and said, we would like to add 3 more sections to this. And they're currently going to take delivery in the next couple of weeks on 3 additional sections to lengthen this out to connect to another, to extend it. So in the industry, we call this accelerated precast construction. It's a concrete industry term. It really goes back to FHWA and AASHTO. They're looking for everyday counts. We need to maximize and speed up our construction. And in FHW and AASHTO, they refer to this as accelerated bridge construction. But we like to point out that accelerated bridge construction is not just girders and overhead things, but some of these underground structures. What that does is when we use innovation to schedule and design and manufacture and do all those things, it reduces our on-site construction time. It reduces our costs. It improves safety. One of the things that's great about doing things in an indoor climate-controlled manufacturing plant is that we have less accidents and less lost time on that. There's many of these plants that will go years without a recordable accident. And that's so much more difficult to do when you're out on a highway, when you're out in the elements. There's also a reduction for road user impacts, these costs of people sitting delayed in traffic. So that's what we're kind of talking about today. Now, when you go out to a precast manufacturer, one of their responsibilities is to give you the layout and the design. You can see here that this is the typical section for a precast box. This will show the haunches in it. You might have other things in the design, openings for manhole access or maintenance access. You may have elbows or other things that come into this process. The manufacturer is also going to give you a steel design. So you can see here that he's laid out how he wants the steel done, which is specific to how he's going to build this. So it's important that the manufacturer have a hand in that. So this is what he would be submitting. It's important to have that stamped in your local state and have an engineer that understands what he's doing. Most of these plants have an engineer on staff or someone they work with that understands the precast standards that we're going to talk about. You can see that. You can see in here that he's done calculations to determine what the required steel area is. Now, as he does those calculations, he may go out and order the steel in such a way that it meets or exceeds the required steel. And that's what he's going to put in, and that's some of the things you'll check in a submittal. Let's talk about the terminology. Let's say someone wanted to order a box culvert, and a lot of times they'll call me and say, I'd like a 6x12 or a 12x6 box culvert. Now, Jason, I'm going to put you on the spot. How should they do that terminology-wise?
The span should be listed first, and then the rise or the height should be listed second.
Okay, and a lot of times we know, because typically for canals and other things, it's wider than it is high, but sometimes there's other things going on. So that's one of the things we always tell people. The other thing is the dimensions are internal dimensions. They're typically, most people's forms are usually set up in even foot increments, although there are options to do those in different increments depending on what's going on.
Hey, Randy,
so Jason, why don't you take the lead? Oh, okay.
A little kind of pertinent to what your previous slide was before the rise and span. The question is, will this webinar be advising on the manufacturer's design principles and the number of recommended or required clips and steel design?
Say that last part again, Kim.
I believe they're wondering how the manufacturer does the design. Are you advising on that today?
Well, Jason's going to jump into the design specifications and where the calculations go. We're probably not going to get into how the manufacturer does, calls out the steel and all that detail. That is not for today, but why don't we go through this a little bit more, and then some of these questions may get answered as we go. So, Jason, why don't you take over?
Absolutely. Here? Thank you, Randy. I'm excited to be able to talk about the most exciting topic in all of engineering, and that's specifications. So hold on to your hats, everybody. Here we go. We're going to have way more fun than we probably should be allowed to have here. So a couple of things about the specifications that we have. First of all, we're going to go through a little bit of a history and talk about some of the specifications that are used in the national level. But while I'm going through this, if you all would kind of think for a minute, if you're a consultant, think about maybe specs you've used in the past or that you've written. If you're working for a municipality or for a DOT, maybe think about what specifications your local specifications are referencing, because we're gonna talk about some of the differences between these specifications, and I want you to kind of get an understanding of what these specifications are, and maybe you'll look at this and go, oh, these are great specifications. Maybe we should be implementing those or referencing those in our local specs. So be thinking about that as I talk through these. So the first one is ASTM C789, which was a box culvert specification, and the AASHTO spec for that is AASHTO M259. Now that was a specification for box culverts with 2 feet of cover or more. Okay, and then there was a second specification in ASTM and AASHTO that was C850 or AASHTO M273, and this was for box culverts, or I guess it is. It's still available in AASHTO, but this is for box culverts that have less than 2 feet of cover on them. And so years back, ASTM said, why don't we combine the two to make one specification for box culverts? So they combined ASTM C789 and ASTM C850 to create ASTM C1433. So this is the box culvert spec that goes from 0 cover all the way down to 25 feet of cover. AASHTO has not combined those two together yet. So they still have AASHTO 259 and 273 are still separate. They have not combined those. A few years went by and they decided, you know what, we need to update this ASTM spec for the AASHTO LRFD design process, update it for the design loading, and so they came out with a new spec called ASTM C1577, and that is the box culvert spec for LRFD. Now, these are the manufacturing and design specifications. So separately, there's another installation specification that is ASTM C1675, and so that is the spec that we reference when we're dealing with installation. But remember, the 1577, 789, 850, 1433, those are for manufacturers to use when they're building these box culverts and when they're designing them. So it has some of the design criteria in there. Additionally, AASHTO LRFD, the sections 3, 4, 5, 12, and 14 are sections that reference these underground structures, these concrete structures. So if you're interested, those are good references for the design. Specifically 5 and 12, section 5 and section 12 get into design of underground concrete structures as well as bridge sections in section 12 there. So load combinations are outlined in ASCE 2697. So that's another design specification that we wanted to mention that you can reference when you're looking at load combinations and how we're loading these box culverts. So I don't know, Kim, do you want to do a poll question now?
Sure, let me launch that.
Okay.
Okay, so the next polling question, again, we're asking this of consultants and engineers, owners, not industry folks. Which national specification does your local agency reference? So what do you use locally? ASTM C1577, C1433, do you use AASHTO, none of the above, or maybe you're not sure? Got about half the folks who have voted. All right. So interestingly enough, Jason, 63% said they're not sure. 16% use 1577, 4% use 1433, which is typical. That's an older standard, with 1577 being LRFD. 10% use one of AASHTO's specs, and 8% use none of the above.
Interesting. Okay. Well, thank you for that. We're going to be talking today a little bit about C1577, and I'm going to show you some of the things from 1577. 1577 is a specification. It's what I call a grab and go specification. This is a specification that has tables that have the different various sizes of box culverts that you can just, a manufacturer can grab it from the table. The steel areas are already laid out. The wall thickness is laid out. The span and the rise are already laid out for you. So, and then there's details in there to tell you how to manufacture this. So this is one that if you're specifying for ASTM C1577 in your spec and you're saying we want a 10 by 6 box culvert, and the manufacturers can just go to 1577, pull that design out, figure out the steel areas, lay it out, and go with it that way. So it's a really slick specification, and it's nice and convenient to use. We'll talk about some of the things with 1577, but then we'll also get into special design considerations. So one thing that 1577 references is that we'll be using a 5,000 psi compressive strength. That is required for 1577. Additionally, you want to meet the concrete performance requirements that are laid out in ASTM C1577. This next slide is just a picture of a table that is pulled directly from the specification. So this is the 12 by 8, 12 by 9, 12 by 10. So it ranges in different sizes, but I just grabbed a few of these tables so you can see what you're looking at when you open up 1577. If you notice on the left-hand side, you've got the design earth cover. As I mentioned before, you had ASTM C789 would have been from 2 feet to 25 feet, and then 850 was 0 to 2. So this has them, as you notice, combined. This can go from 0 feet of cover all the way down to 25 feet of cover. So that's on the left-hand side. And as you move across the page, you've got your steel areas, your AS1, AS2, all the way up to AS8. So I'll show you in just a minute, but before I get there, I'll show you where those steel areas come from. But if you notice, there's 3 numbers there. You've got 12 feet by 8 feet by 12 inches. So Randy, I'll put you on the spot. I'll return the favor. What is that 12 inches referring to?
12 inches is the thickness of that typical box culvert section.
Okay, so that would be all the way around. That would be top slab, walls, and bottom. Is that correct?
That's correct. Now I want to put you back on the spot, Jason.
Okay.
What if we had to go deeper than 25 feet?
That's a great question. If we had to go deeper than 25 feet, we would have to do a special or modified design, and we'll talk about special designs in just a little bit. But this is a typical section. On the left, you've got your fill heights less than 2 feet, and on the right, you've got your fill heights for 2 feet and greater. So this is where it shows you where all of these steel areas are. If you notice, we've got AS1 is going to be your outside steel. So that's going to be that outside cage all the way around there. AS2 is going to be on the top slab, your inside cage. So your inner cage on the top side there. Your AS3 is going to be the same, but on the bottom. So it's that inside cage on the bottom slab there. So the one closest to the inside of the box there. Your AS4 will be your sidewall. So it's only shown on the left-hand side, but that is your sidewall steel. AS4 is your sidewall steel. When you get into lower spec, if you notice on that spec or that table that I showed before, you only had AS5 and 7 and 8 on the design cover of 0 to 2 feet. So you have to put additional steel in there when you're driving right over to. There's a very low earth cover on there because obviously the live loads are not being distributed as much. So AS5 on your low cover boxes is going to be your distribution reinforcement on the inside cage on the top slab. Your AS7 is your outside reinforcement, so your outside cage, your distribution reinforcement on the top slab, and then on AS8 is actually your bottom, your outside reinforcement, so that outside cage or distribution reinforcement on the bottom slab there. So keep that in mind when you're pulling these out. And this is what the manufacturers do. This is what they're looking at. But you will need to reference on your plans. Randy talked about just what you put on the plans. You need to show how much cover is going to be on there. So we want to see a typical section. We want to see a profile view so that our manufacturers can determine how much cover they are to see if we need to use what box we need to use, what size we need to use in the table. So we'll just match that up. So next we'll talk a little bit about reinforcement. There's 2 different types of reinforcement. This is a tied rebar. This is very common. Most of us engineers remember doing designs with rebar in college, and this is very common, and we use a lot of tied rebar, but there's a second type of reinforcement as well, and that is a welded wire mesh or welded wire reinforcement. And what this is, this comes in sheets, like big sheets. It's like a welded wire mesh. You fold it and you bend it to fit the configuration of your box. Now, one thing to keep in mind, and that manufacturers need to look at when they're doing this, is rebar and welded wire reinforcement have different yield strengths. So the steel have different yield strengths. So if you're designing, or if a manufacturer's designing this to use rebar, and then they decide, oh, let's use welded wire instead, they have to modify their design and change that because of the difference in the yield strength there. So that's what manufacturers will keep in mind, and we'll talk a little bit more about that design and how that affects in just a little bit. But I think Kim has a poll question for our manufacturers. We were just curious to see who
Jason.
What? Yeah.
Jason, you may want to point out which has the higher yield strength, though.
The welded wire actually has higher yield strength.
Yeah,
which
Jason,
a lot of people
before
don't know.
I launched this poll question, we got a couple of folks that had a couple of different questions related back to your chart that shows the different steel, the AS5, the AS2. They wanted you to go back over that. What each one is used for.
Okay, absolutely.
Yeah, I think I got three different questions about that.
Okay. Well, Randy, if you go back one slide further, and let's look at the table again. So these areas I should have pointed out. I apologize, but these areas. So if you look at the AS1 column, let's say we're looking at 10 feet of earth cover, and we go over to AS1, we're at 0.34. That is 0.34 square inches per foot. So that's what that steel area is. And then as you go over, so AS1. Now let's go back and look at the other drawing there, or the other section. So AS1 would be that outside cage on the. It would go all the way around it for the 10 foot because it's just that outside steel cage. AS2 is going to be your bottom. So that bottom reinforcement there on that lower cage. On the inside cage on the top slab. Okay, let's go to AS3 there, Randy. So AS3 then is your bottom, but it's the bottom slab, but it's the inside cage there. So those different areas. So if you notice, some of those areas in that table, they're going to be different. So as you go through, you can't just say, well, we'll just put this much rebar, number 5's at 10. We'll put those all the way around it. The manufacturers have to check and make sure that they're pulling the right design off of there, and they're determining what those steel areas need to be, not only just for the inside cage and the outside cage. Sometimes they can be similar, but at times you're going to have, you could have 6 or 7 different steel areas depending on where you are in the box. So it's very important that the manufacturers are checking that table and watching it. And it's very important that the municipalities and the states are inspecting those to make sure that we've got them right as well.
Jason, that brings up a good point. The point being, as a manufacturer, we may look at that and we may put higher steel in some of those just because it doesn't make sense manufacturing wise to split them all out. So we have to look at each box separately, and each manufacturer may do it a little bit differently. So
right, that's a good point. Good point. Okay.
One other question, Jason, that you didn't touch on that I got 2 questions about is the difference between the AS2 and the AS5 there at the top.
Okay, great question. So the AS2 is the one, if you look at it, that's the one that's going across. So that goes from the left side of the box to the right side of the box. And so that would be, I guess, what we would call the hoop steel that goes around it. The AS5 is the steel that goes longitudinally along the box. So that would be, that goes in each span. So if you've got a span of, a lay length of 6 feet, that would be 6 feet of steel that would go from along the lay length of that. Does that make sense? I don't know if that.
So AS2 and AS5 are perpendicular to each other.
Correct.
Clarify. Okay. Well, let's keep going, and then some of these questions may get answered, and some of these may be another webinar that we do. Maybe we do one in more detail. This one's meant to be kind of a overview of how you would specify things. as a designer, you wouldn't need to specify any of that. You would probably need to be reviewing it and coordinating with the manufacturer. So
right. You want to do that poll question now, Kim? Or?
Sure thing. All right, so our next poll question talks about, again, for, this one's for the manufacturers, right?
Yes, that's right.
Please estimate what percentage of your box culverts are made with welded wire reinforcement. So engineers and consultants get to take a break here. We're really asking the manufacturers on the call how much welded wire reinforcement, what percent are your boxes made with that? All right. Give them just another minute or two. And here's the results. So 80% or higher was 55%. So the majority of them make the majority of their boxes with welded wire reinforcement. I think that's the point of that one.
Excellent. Well, thank you for that. That's good to know. Very good to know. So ASTM C1577, as I mentioned, grab and go spec. It has a very, a lot of different sizes, and it goes from a 3 foot by 2 foot, so that's 3 foot span by 2 foot height, up to a 12 by 12. So Randy asked the question earlier. Well, what do we do if we have one that's over 25 feet? Well, another question would be, what if we need a 15 by 10 box or a 20 by 10? What if it won't fit in those sizes? That's when we need to look at a special or modified design. So a special or modified design would apply to any sizes that are not included in that table, like I discussed. If we need any modified thickness, if a manufacturer decides they can do their own design to change that thickness a little bit, so they can maybe save a little bit depending on the design and loading. Also, if you do have different loading from what is put in 1577, as I mentioned, ASTM 1577 is an LRFD design, but sometimes we have to do airport loading with FAA, railroad with AREMA, or if they're really deep fills, there may be some different loads that we're not taking into account. So that's when we would have to do where our manufacturers would do a special or a modified design. So when we do those, there's a few requirements that we look at and a few things that our engineers are reviewing when we look at these. First of all, we want to make sure they're a rigid frame and that there's 2 cages. We provide 2 cages in there. It's very important, and I'll show you why in a moment, why we need the 2 cages. And we're going to go through these pretty quickly because I'm going to go through each one in a little bit more detail. So your load combinations are included in the ASC 2697, as I mentioned earlier. Design load criteria is included in C1577, and I'll show you what that design load criteria is. We also want to talk a little bit of crack control. That's something that that our engineers are taking into account while we're designing these. And any special designs need to be prepared according to AASHTO LRFD section 12, where applicable, obviously. But that's what we're recommending, and that's what we're doing in our market here. So this is just a sample moment diagram. And the reason I show this, and I wanted to show this, is because you can see that you've got moments going from positive to negative. And so the worry is that if you're putting the steel in and you're only putting 1 cage in and you're putting it right in the middle of the box, you're kind of missing the positive and negative moment zones. You're missing those areas where it really needs it. Additionally, those moments kind of bend around the corner. So it's really important that we have the right amount of steel and the right number of cages, because if we only have 1 cage of steel in there, you may be missing some of these other high moments. If you've got the cage of steel on the inside and not one on the outside, then you're missing those positive moments around the outside there and around the corners, because that's where that moment shifts. And so that's why I show the sample moment diagram, because it changes a little bit there. This spec, again, we just looked at this, but if you notice on both of these, they've got the inside steel and the outside steel going around it. So this is ASTM C1577 shows the 2 different cages of steel, 2 specific cages. So that's why we recommend that you do everything with 2 cages of steel. This is the load requirements from C1577. If you notice in note 3, we already talked about the strength of 5,000 psi earlier, but in note 3 is where I want to focus here. These are designed, the loads are designed on an HL93 live load. However, it's designed without the lane load, so keep that in mind. It's HL93, but you don't have to take into account the lane load. However, it does recommend and require that you look at the design truck or the design tandem and then determine which is the controlling case. So on the next slide, I've got a picture of obviously the design truck, and then this next one would be the design tandem. So you would have to look at both of those. Our manufacturers, as they're doing these special designs, need to look at both and adjust accordingly. In AASHTO LRFD, there's crack control. This is the crack control section that talks about how we need to distribute the reinforcement for crack control. If you and then the next one shows, the next slide shows these are the equations that we use for this. So these are things that you need to be taking into account: the exposure factor, the stress, the tensile stress of the steel, the thickness of the concrete that's measured to the flexural steel, the distance from the compression fiber. So these are things that we're looking at with crack control. One thing to keep in mind is that these AASHTO LRFD equations, what we've noticed in our experience is that these are designed specifically for larger, thicker walls with 2 cages of steel. We were designing some catch basins, and we noticed that when the smaller sizes that only had 1 cage of steel right in the middle of it, the D distance was throwing it off, and so we were getting much deeper fills and much deeper depth than we normally would have gotten with using 2 cages of steel. So keep that in mind, that these AASHTO LRFD crack control equations were designed for thicker walls like you would see in a box culvert. So sometimes you may have some issues on some of the smaller design like catch basins and other underground structures. So keep that in mind. This is the header for section 12. This is just what you would look at when you're preparing special designs with LRFD. This is the section that talks about buried structures and tunnel liners, which box culverts fall into there. One thing to keep in mind then is that this is a software that I wanted to talk about today. We're not going to get too much into it, but I just wanted to give a brief introduction into Culvert. Culvert is created by Ericsson Technologies, or Ericsson software. It's a rigid frame design and rating software that has been partnered. Ericsson Technologies has partnered with ACPA to make sure that all of the loads and everything that we're seeing are taken into account in this software. So the American Concrete Pipe Association has partnered with Ericsson to determine, to make sure that we're taking everything into account with our members and our manufacturers and what they're using. So I wanted to talk just a few points of what Ericsson, some of the benefits that Ericsson or the Culvert software does, and some of the things and some of the reasons why our manufacturers like them and why it's convenient to use. So it does support multiple specifications, including AASHTO, and with that, it has the standard and LRFD with AASHTO. It also has ARIMA. We've got the ARIMA design in there, and the CSA S606. CSA S606 is the Canadian equivalent of the AASHTO LRFD. So if you're doing designs, box culvert designs in Canada, that's the specification that you would use. So it is included in Culvert, so you can use that there as well. It also has automatic fully parametric design. It checks the multiple trucks automatically, so you can look at different design trucks. You can look at the design tandem. It checks those automatically for you. Also, it can do a design for rebar and mesh reinforcement and compare the two. So as I was talking earlier about the different yield strengths between the steel, the rebar, and the welded wire, this program will run them both and check them for you so that you can determine which one you want to use based on your inventory and what our manufacturers have available at the time. And then it will create a complete bar and wire table for you so that you can determine, all right, what do I have in inventory? What do I need to use for this? And then you can order and have everything prepared and ready to go. So it's a really convenient program. It's a great program that ACPA has teamed up with Ericsson to make sure that it covers what we need it to cover. So we're really happy with it. But next, I wanted to talk briefly about hydraulics. We want to talk Manning's roughness coefficient and just point a few things out here. When we're testing these in the lab, and obviously lab results are, you're using a very controlled environment, but we were able to get, in the labs, we're able to get a Manning's N value of 0.01, which is pretty low. and it's pretty impressive that they can get that in these precast structures. However, the recommendation is that we use a 0.012 for storm sewer. This would take into account some of the things that we're seeing in the field, and it would more closely duplicate field conditions. So even though in the laboratory we can get a low Manning's N, the recommendation is that we drop down to a 0.012 for your design purposes. Now, if you were to pull a table and you were to look at a box culvert, a concrete box culvert, some of the tables that I've seen show a 0.015 and not a 0.012. And the reason is that 0.015 is for cast in place box culvert. So if you were to do a cast in place box culvert, a lot of times those cast in place, you've got rough form marks on the bottoms and on the sides. And so those rough form marks would increase your Manning's N from a 0.012 to a 0.015. So keep in mind, if you are using precast and if you're specifying precast, you can use a lower Manning's N, which in some cases can decrease the size of your box and could be significant cost savings to the city or to the DOT or to whoever your client is. So keep that in mind, the difference between hydraulics of precast and cast in place. Another thing that C1577 discusses is skew. So if you look on the left-hand side, this is a picture of a box that goes straight across the traffic. So it's perpendicular to the traffic flow. Our flow of our stream is perpendicular to traffic flow. So that would be a zero skew or no skew in this case. C1577 says that the designs included in there are applicable and acceptable up to a 30-degree skew. So if that stream or that box is skewed up to 30 degrees from traffic, then it's okay. You can still use those. You can still use those tables. However, anything over 30 degrees, you have to do a special design. This next picture is a drawing of a project where you can see, if you look on the left-hand side, you've got your box culvert running from left to right across the screen. And then if you look just above it, you've got the SB and the NB, the southbound and northbound lanes. So they've identified what your skew angle is there. And if you notice where the cursor is there, that says 27 degrees. So at first glance, you say, oh, it's only 27 degrees. That's unacceptable. We can use these designs. The problem is that's 20 degrees, 27 degrees from the horizon. We need to go from the vertical side, right? So it actually is about 62.5 degrees. So it's more than double what the acceptable amount is. And so you've got to be looking at these and determining that what the skew angle really is. In this case, where it's 63 degrees, you would have to do a different design because the way that traffic is interacting with our box culvert and our steel layout and our steel design, where maybe before if your hoop steel was the load bearing steel, now it becomes your longitudinal steel. So you've got to take that into account, that if it's beyond 30 degrees skew, you're going to have to do one of those special or modified design and check on the load rating. And speaking of load rating, I know Randy is pretty passionate about load rating, so I'll let him maybe talk about that for a minute.
Kim, do we want to, I know we're about 15 minutes, and I think we can push through and finish for everyone in about 15 minutes, but why don't we take another poll question real quick?
Okay. All right, so this is your next polling question. Do you require that the precast box culvert manufacturer meet a QA/QC program in your specifications? So again, this is for the engineers and consultants owners on our call. So do you require some type of QA/QC program in your specs? That could be like the QCAS program, which is the ACPA QC program. All right, I'm going to close that and we'll show the results. So it looks like 67% do require some type of QA/QC program. That's great.
No, that is great. Thank you. These polls are interesting and they help us to know what's going on in the industry better. So as we talk about load ratings, in FHWA, a 20-foot span is considered a bridge, and 20-foot spans need to typically have load rating depending on what highways they're on. this is out of FHWA guidance. This shows 3 culverts, and if you look, they measured this the actual span if it's skewed along the center line of the highway. So this section BB would be where they would look at that length, and they would take the cosine, divide by the cosine of that skew angle to come up with whether it was a 20-foot span or not. So in the case of the one that we're looking at, a 10-foot span at 63 degrees actually became a 22-foot length across the center line of the highway, and needed to be load rated in that case. So there's things that come up. I would work with your look at your local state requirements, how things need to be load rated if they're load rated, and it does introduce other things into the design that you should coordinate with the manufacturer. Now, to summarize what we've talked about earlier, when you go in and do this, people have asked me, what do I say on the plans if I just want to do precast? And so this is an example note. I don't know if this is ideal, but this was install a 10x6 precast concrete box culvert. The selected manufacturer, so you don't know who it is yet, but they will design, stamp with their professional engineering stamp, and submit a box culvert for your approval that meets ASTM C1577 and whatever other project specifications you have. So you need to outline those in your project and have good specifications. And that's another thing we could talk about if we, in another webinar at another time, all those things that could come up. So one other thing we wanted to point out, and it's interesting, we had someone tell us, well, on this project, cast in place was so much cheaper. And we thought, that's really strange. In fact, with cast in place, you typically have to have different cover requirements and different things in there. You probably will need to have more steel if it's designed correctly. Similar amount of concrete typically. And we went out and looked at a project, and they had like 40% of the steel of what would have been in the precast. And we've looked at some different plans, and sometimes people aren't following these AASHTO standards, and there might be other types of structures out there. Everything ought to meet an appropriate design standard if you're comparing them, and that's important when doing a bid or doing specifications. So we're going to jump into bedding and installation. Now, one of the questions I know that's come up in the past is, how do these perform long term? Do you get settlement? How do these react? Well, one of the keys is to have proper bedding and installation. This box culvert really will act as a footing and do very well if you deal with the bedding and foundation underneath it. If you've got soft soils, which are not uncommon in a canal or other rivers and streams that you're in, you may need to over excavate that. We really like to recommend you have a geotechnical report, that you look at what needs to be done, because we will just typically call out a minimum of 6 inches of granular material. We like 3/4 inch max. We like a small material in there, that not real big things. And the reason why is you need to have this very flat. Now, the other thing, Jason talked earlier about ASTM 1650, which is the installation requirement. In there, it calls out a leveling course. Now, we like a pea gravel or a sand leveling course, something that can be raked. This isn't meant to be structural, but what it's meant to do is have that box sit very flat. So as we go through and look at those, one, we want to have a laser out on the project. You need this for horizontal, but you also need it for vertical control.
Hey, Randy,
you want that
I have a
box
question for you, since you asked Jason and Jason asked you. So oftentimes we get the question, is concrete an acceptable leveling course?
It can be, but what you have to recognize in this is, when we manufacture these, they're manufactured on forms, but there may be some little variances in the forms. It may not be completely flat along the bottom. So we had someone that came in and they said, we're going to do a crushed concrete. And it was very difficult to work with, and it was very difficult to ever get flat, and it would never match the exact flatness of the box. So I would still recommend that you'd have some kind of leveling course in between that, because a pea gravel or a sand or something like that can level out to match the minor imperfections that are in a box. Concrete to concrete, you'll never have it match up exactly. And that's my opinion. So
yeah, that's my opinion as well. Is we never want to see concrete as the leveling course for the exact reasons Randy just talked about. One other question similar to that is CLSM an effective leveling course?
and you would have some of the same issues if you're going to do it. It would be difficult to level out. I don't know how you'd ever get it to match. You can even get mud on the bottom of a box culvert, and we recommend to clean that off. But those little things that go in there, that will make it very difficult. The process that I'm going to show you now, and as we go through this, has worked very well for us. And if you follow this, we've had very good success, and the box culverts go together very well. If you don't follow this, sometimes the box culverts don't want to go together. Like we had a project where someone had 3-inch minus material under the box culvert. Well, 3-inch minus ended up being like a tippy tabletop with 3 legs. The boxes didn't want to go together, but as you added in a leveling course or finer material in there, it worked a lot better. But you can see here, you want to have a laser on horizontal center. You want to keep that and shoot line down the center and make sure you're following that alignment. You also want to work with and follow your grades. The grades need to be really flat when you're building a box culvert. Now this shows
Randy,
first
one other
question
or comment on your last slide there. It was suggested that screed boards are highly preferred to laser and spot. So that may be regional or dependent on your contractor
right.
and your local owner and what they prefer to use.
Right. Yeah, and I kind of come into that here later as we go. So the question mark there shows typical. Your lay length is going to be according to the manufacturer. So I took off what was typical. 6 to 8 feet is kind of some of the more common lay lengths. It really depends on the weight and what you can ship and the size of the box. As we look to do installation, you can see that this box has the groove end or the bell end pointing upstream. That is the way you need to install. And you're going to pull the tongue into the groove, and you want to pull that in, and you're going to install from left to right, and you're going to pull the right into the left. Now, as you do that, you can see this one here, that the groove is on the left, and they've dug a small shovel trench right in front of the groove so that if any gravel drags, that it won't drag into the joint, that it'll spill into that little shovel trench. As you go there, you'll see that they break this out. Now you could use screed boards. You could use different things. We've seen different contractors use different things. We don't try and get prescriptive about how they'll do it. What we try and be specific about is that they are getting it very flat and that they're checking grade cross slope longitudinally all the way around. You want to keep the weight of the box on the crane as you're getting it there. So what he's going to do with this is he's going to bring it very close to that other box before he even starts to lower it. In fact, he can have it almost inserted there before he starts to lower it. Now we're going to talk about mastic. Mastic's probably one of the more common sealants. There's different things in different markets, but a bituminous mastic joint that you can see in the photo is specified in ASTM C990. You want to make sure you have the right mastic area. We recommend 1 inch to 1.5 inches square. We have had jurisdictions that have said, well, if mastic's good, double mastic would be better. And double mastic is not a better situation. These box culverts have an annular space that's designed to accept that mastic that's called out. And if you double up on that, they're not going to go together well, and you're going to have other problems. Mortar grout is not required in these joints, but what these joints are is, with the mastic joint alone, they're not considered watertight or pressure rated. Now, if you have a watertight or pressure job, you can do other things as far as sealing these. You see other sealants on the inside. This job that we talked about, they had a long run here and they had no leakage over it, and they used an interior sealant on all those joints. And that was because they had special requirements. If you had a pedestrian tunnel, you may not want even a little bit of leakage. In most cases, a mastic alone achieves great water savings over what they've had in some of these other cases. They've had so much leakage that they really haven't seen very little with the mastic joint. As you can see here, we find that a contractor typically can pull these to an average about of a ½ inch gap, which is recommended and fine. You can see how the mastic will be placed on the leading edge of the tongue, and it will roll back as the tongue is pulled into that joint. Jason, I'm going to ask you here to do a little bit of quick math. We've got 12 boxes here with 6 foot lay length.
Okay.
So why would that add up to 72 foot 6 inches?
Well, each box should have about a ½ inch joint gap there. They're designed to have a joint gap, so that 12 times ½ inch would be an extra 6 inches, so 72 feet 6 inches.
So that's great, but that's a critical part to recognize. If you've got a long run and if you've got 400 boxes and the contractor does different than the layout, if he had an elbow or a manhole or something that he was coming to, it would either shrink or grow depending on how he's doing that. So that's something you need to keep. Yes.
Perfect timing to go back to this picture. There was a question of why some of the mastic is on the bottom and some is on the top in this picture.
Yeah, and that's what I'm going to explain here. So as you can see this, we put up to the haunches in the tongue or the bell of that. And the reason why we put that in there is if we tried to wrap it around, if we tried to wrap it around the tongue, and I said that wrong, the groove over here is where we put it. If we tried to wrap it underneath the tongue, it would just fall off. Mastic won't achieve what gravity is going to do to it or overachieve. So what ends up happening there is we put the bottom half, we recommend down in the bell, and we make sure that they come together or overlap just a little. So there's a little measurement that needs to go on. And the top part goes up along the sides and over the spigot or the tongue of that. So that's a recommended thing, and you can look at the manufacturer's recommendation. A winter grade mastic.
On this topic is what, and it's a kind of a interesting question dependent on your region. What type of sealant would you recommend?
Well, I think you're going to have to work with each of your regions. As we talk about, a lot of times here we'll use a winter grade mastic. We would be working out there today, and we may have the contractor put that in the cab of a truck or something to still keep it warm, but winter grade mastic below 50 degrees. If you're in other jurisdictions, you may do other things. Now, as I'm going to show you here, a gasketed box culvert is also something that there's a spec out there for, but it's not available in every region. So what ends up happening is you want to coordinate with your manufacturers because, as you can see, this needs to have a rounded corner on it to do a gasket, and it takes a lot of modification to the forms and everything else. So it may not be available yet, but that's another option that's out there. So we don't want to, we're trying to keep this general because the local manufacturers may have ways to do things, and it may be better for their market. And it doesn't mean these are all functional. There's not a one right way to do anything. So as we go through this, we talked about the ½ inch gaps. This was an example of where they use shims within the box culvert to pull that together so that they could know where that ½ inch was. So we've seen that done. The box culvert should be marked, and this is in the specification. The date, the loading, the size, and the section. You can see here that the manufacturer's name was on there. You can see this part F. This part F indicated on the plans that an elbow needed to be there. So the contractor needs to make sure and find that part F. Now, it's sometimes not that hard to find that, but he may have different elbows in the project, and these can be made. He may have different manhole openings or maintenance openings. He may have different loadings on the project where part A and part B are designed for different depths of fill. So he needs to watch those. Now, as we get into installation, this shows what was typically used as a manhole puller. The manhole or the pipe puller, this was wedged into the box culvert, and then hydraulically these would be pulled back together. You can see where they use these I-beams to pull these back. Now in our market, we've done something a little bit different. We've used pulling inserts, and we actually pull them together with come-along devices. But what you don't want to do is you do not want to push those together with equipment, because they'll bind up and you'll have other issues. Now, as we talk, we're just going to finish up here real quick, and then we can take some other questions from those of you that want to stick around and have questions, and the rest of you may be done or not. But as we talk about scheduling, the contractor needs to really know the weight of each section. We find that the contractor sometimes wants to skimp on equipment, and maybe he doesn't have capacities he needs. So we try and work with them on pre-con meetings, make sure he understands the weight and the boom length, the number of sections per load. He needs to know what's coming. He needs to know what joint sealant's going to be used, and he needs to know a delivery schedule. Often we start out with, when we deliver, that early on in the project, we're setting up the alignment, we're getting going. That first box may take an hour, where subsequent boxes may take half hour or 15 minutes each. So it's important to coordinate that with the contractor, how the trucks are going to arrive, the different things. We wanted to point out that some jurisdictions think that all the wing walls need to be cast in place. These are precast wing walls out here to the side. Those were 3 pieces that came together. They have footings down underneath them. They're weld plated together. They're an option that's available. Excuse me. We need to recognize that these aren't just for waterways or culverts. These could be pedestrian crossings, or my favorite, a golf course crossing. In the specifications, you need to call out the backfill and get this backfilled correctly. Now, you'll remember that Jason designed these, or talked about these are designed for 0 feet of cover. As you're backfilling that, there's options to get equipment out there, but it needs to be consistent with the design. And we always recommend they put some material out there so they're not just right out on top of the box culvert. There are other projects we've done. We've done beveled box culvert. This is a plan that went up, and you can see we made the ends so they weren't perpendicular. So this is something that your manufacturer might be able to do. This shows a box on the right with a 5-inch bevel, which, as we put all these bevels together, we were able to fit a very tight alignment with a lot of curves that we typically wouldn't be able to do. So that's, we put a lot into an hour there. And please send us comments about other things you may want to go over. We'd be happy to have other people at ACPA and other people talk in detail about other parts of this process. So this is just kind of an overview. But what you've learned is you can design this and have your manufacturer design it to the right loads and specifications. You can specify these, and you can go in and put these in your project, and then you need to coordinate the contractor installation. So with that,
hey Randy,
before
we get
open it up to questions.
Before people hop off, because I'm seeing some folks having to jump off, a couple questions about the webinar. Will it be available after? Yes, we are recording this webinar. We'll send it out to all those who registered to be a part of this this webinar, so you will get that probably either today or tomorrow. The other thing I wanted before people hop off is we would like to know from the consultants and engineers, owners on the call, what would you like to see next? We're going to send out a survey. It will pop up when you close this webinar, and then it'll also go out in an email, so you can look for it either way, whichever is more convenient for you. But we'd love to find out what you'd like to see next. So with that, we'd certainly we have a lot of questions coming in. Randy and Jason, I know you guys would stay on as long as people want to hear more questions answered. But if you're not available, thank you for your time, and we appreciate it. And we'll be sending out another notice for another webinar probably in the next month or two. So thanks so much. Randy, one of the questions I got was, what is the specification to install a box properly. And that would be ASTM C1675, if you're interested.
Yeah, I may have said that wrong. Right. And that is that specification's fairly generic. It doesn't go into a lot of details because it doesn't want to get prescriptive. In our market, we're a little more, there's certain things we found that work a little bit better. And so I would consult with your marketplace. And when we send that out, I think we'll provide Jason and I's email if people have other questions. That might be the easiest way if they need other information. So.
Yeah, I was actually going to go to our website and show you where you could get a hold of any of our staff. So, Randy, I'll take back control here, and I'll just show folks where you can get your questions answered. All right. Just a second here. Randy, I don't know if you can see the questions while I'm getting this put together. You open up the question pane, you can see there's quite a few. Okay, I'm showing my screen now. This is the ACPA website. You can get there by just going to concretepipe.org. And if you hover over association, then meet the team and staff. You can see all the staff here. This is me, Kim Spahn. This is Jason, who did part of the webinar as well. He's on our staff. Josh Beakley, as well as very good technical resource for the ACPA. I know Russell Tripp is on the call as well as our president. I will leave it at that. The top four of us here on this call are probably the best folks to reach out to if you do have questions. But certainly there's other folks that may be in your region. For example, Walt Catlett's in the Southeast region. If you reside there, feel free to reach out to him as well. On down, you can see our staff. But if you just click on each of our names, I take that back. Our emails are not there. My email, if you want to get a hold of me, which I can get a hold of any of these folks, is kspahn, so just my first initial last name, at concretepipe.org, same as our website. So again, kspahn at concretepipe.org. So reach out to me. We'd love to answer all your questions.
Kim, on that, I don't know if I have the ability to see the questions. So
okay.
If there's anything else you want to.
Yeah, we still have 275 folks on the call. So if they're interested in some of these questions, we'll keep asking them. So is AS5 supposed to be a distribution steel for AS2 and AS7? I'm going to flip it back to you, Randy, so you can go to that slide.
Okay. Jason, you want to?
Yeah, AS5 is the distribution cell still there on the inside cage on the top slab.
Right. Are the tables based on rebar or welded wire reinforcing?
They're not based. Well, they would be based on 60 KSI steel, but they're just giving you an area steel for that 60 KSI. So if you were doing welded wire, you could still use the table and you'd be over designing, but otherwise you'd be designing to welded wire in your submittal.
Great, thanks, Andy. Let's see. This one, I think it's talking about spacers. Are there ASTM requirements for clipping, or does it just have to be a minimum cover? I think you might be talking about spacers.
Yeah, the minimum cover that's required over the steel is 1 inch in most of these. There are some maybe exceptions in different places, but you're going to put a clip inside the form that it's going to provide you with that. The manufacturer needs to put enough clips to make sure he can hold the steel in place, and it's going to vary based on how much steel you have and how much concrete you have and the different loads you have. The bigger the box, the more loading you have when you put that together, but you also have probably a stiffer steel in there. So it's going to depend, and that's something where we would invite people to come into the plant. Your plants will allow you to come and inspect the boxes either while they're being made or after, and you can be part of the process. But rely on your manufacturer. They know how to do their QA, QC, and that's not going to be in any spec anywhere, I don't think, of how many clips you need to use.
All right, that was another question actually, is the outside cage 1 or 2 inches of cover? And I think you've already answered that. I would say I do believe in some areas that are close to the ocean, it may require 2 inches, but for the majority of the U.S., it's 1
And
inch.
it's typically 1 inch of cover, but I think there was some variations in the spec for real shallow or in different locations. So that's where you got to read the spec and make sure you're following the specification.
All right.
That does bring up an interesting question, Kim. If you're to change the cover, It does change your design. So if you're following the table, you need to follow what's in the table. And if you actually put more concrete cover, you're going to have to add more steel. So it's going to change your design. So those are different things you need to coordinate ahead of time.
Okay. Is any loading assumed other than earth pressure for the buried depth on the tables?
The table includes HL93 loading, which would be the live loading, and it's gone through and checked all the cases that Jason talked about in AASHTO. So in the table, it's checked all those different combinations and things you should do. If you're not in the table, you should follow the same process and check all those. So you may have to check full of water. You could have an above ground culvert that's full of water with no loading on the outside would be a different case. Not always necessarily a controlling case, but you should check all those things in the process.
Yeah, and then if you have a surcharge load or something like that above the box, you would certainly need to do a special design.
Right.
This goes right into another question, whether or not ASTM includes airport rated box culverts.
It wouldn't include the loading in the table. And the most difficult part of doing airport rated box culverts is getting the airport to give you the right critical loading, because different jets put more impact on the runway. You could have what may be a smaller, like a Learjet, that would have more impact because of the way the wheels are configured. So you really need the wheel loading from the airport to design those. And that's where you coordinate with the FAA and on their project and everything else.
Okay, so no lane load, let's see here. So would that just be an HS-20 or tandem vehicle? That might have been as we were talking. I'm not sure exactly what they're referring to there. Sorry about that. If you want to email us that question, maybe we can get that answered for you. Does ACPA have a sample or recommended spec for precast culverts available on the website? Unfortunately, not a specification. We do have guides and things like that, design data, but if you are really doing this for a project, you should follow 1577 or an AASHTO or a Canadian specification.
Now, Kim, I have a sample specification that we have written, and certain areas in Utah have used it. If anybody wants to go to mountainstates.concretepipe.org, you can find a sample specification in Word and PDF that you're more than welcome to take elements out of that and see if it fits your project, and if it would be, I mean, everyone's welcome to use that. So if anybody wants to go to mountainstates.concretepipe.org and look at a sample specification that we've written in Utah, it may not apply all across the country, but it's probably a good start.
Yeah, you should still coordinate with local manufacturers to make sure what their capabilities are. So.
Okay, so this goes more to the part Jason was talking about with Manning's End. Do you design for any debris or sediment in the bottom of the box? We work with a lot of canals, and it's very common to have
silted up bottoms in these. There's different ways they deal with them. A lot of times they're in their design, they're probably providing for some freeboard or other things because they want to work with that. The other thing is sometimes what we'll do on those is we'll recommend people to set the box a little bit lower so that when it silts in, some of these are so flat, like we have a 1.5 foot slope longitudinally along these. So they're so flat that sometimes it's better to set it a little bit lower so that the flow line silts in and maybe you have an inch of silt on the bottom, but that way you get a good flow through there.
Okay, great. Because this kind of stays with the Manning's Inn discussion. Locally, they are using 0.015 for precast boxes because the local agency says the joints increase the roughness. Or the lab results for an install that has no bends, etc.
So the lab results are mainly for concrete pipe, but is my recollection. But the lab results were 0.010, so that was clean water, that included the joints, those kind of things. The reason ACPA recommended adding 20% of that is to have a safety factor to deal with field values. Joints aren't always exact. You've got bends, some other things. To go to 0.015 is pretty extreme in my mind, and I think it really comes from an FHWA number that was more meant for cast-in-place culverts with very rough surfaces, some of them, and some of them that had really deteriorated over time, which I haven't really seen in precast.
All right, great. Thanks, Randy. Another question is, CDOT requires, that's Colorado DOT, requires the use of AASHTO for rating software, which is very expensive. Have you heard of others in the States? I can field this one if you want. We are working with what Jason was talking about as ET Culvert to get that system talking with AASHTO. And so in the very near future, manufacturers and designers alike should be able to use ET Culvert for states like CDOT that want it to communicate with AASHTO. And the deal behind that is CDOT's bought AASHTO, which is very expensive for them, and so they don't want to have to go back and forth between systems. So we are working on a solution there.
That would be great because the AASHTO is very expensive, and those spans aren't everyday spans, so sometimes it becomes difficult to do load ratings. That's why we talked about it. You want to know if you have to do it up front, and you want to have it before you bid the project.
Okay, what is the design criteria for post-tensioning strands?
Okay, so I have some experience on the post-tensioning side, and we're not going to really talk about that today, but what happened was somebody decided that they wanted to post-tension some box culverts together, and it's really not to put a lot of stress and try and post-tension those. The tolerances that are in those to ASTM make it so if you go concrete to concrete on those, you would have stress points and point loads on those that would cause cracking. They're not really meant to be high post tension. And we really haven't seen a reason to do a traditional post tensioning on those. When we get those together, in fact, the one we need to pull apart coming up so that we can add some sections to it, it's going to be very difficult to pull that apart. The tongue and the groove on this typically overlap about 4 inches, and to get that removed with the mastic is very difficult. So I don't know that I answered that question completely, but it's probably a topic for another discussion. But typically in box culverts, you don't post tension like you would do slabs.
All right. Next one is talking back to your bedding, the area you were talking about bedding requirements, Randy. The question is, what density is recommended for the 6-inch bedding?
I think we'd want to get, I'd have to look at the specs, but I think we'd want to get 95% in there. We'd have to look at that. One of the things is typically that's a lot of rock, and you're not going to be able to measure that density. But you really want to have that consolidated well if it's rock and a gravel, and then try and get that really compacted well, and then have your leveling course over the top of it really compacted and raked out well, so that won't have any settlement at all. But that's been something that's been very easy to accomplish within the specs. I think as we've worked with contractors on that, that's gone very well.
Okay, next one is, what about, I think it's in the same discussion when it came in, what about geocell?
So you're talking about, help me with that, Kim, I didn't hear it very well. But
the question just says, what about geocell? I think it came in at the same time you were talking about bedding.
I'm geocell. Did you say geocell?
Yes.
I'm not familiar with that term, and maybe that's just something different that way. I don't know.
I'm not familiar with it either, but it looks like it's, I'm just Googling it. It looks like it's kind of a mesh that they put on the ground for a leveling course. I would say we typically don't recommend that, since neither of us have ever heard of it. I wouldn't recommend using geocell.
Okay.
All right. Are gasket seals being more commonly specified, and what are the benefits of doing so?
Gaskets are becoming more common, but they're not everywhere yet. As far as you can test and have a pressure rating on gasketed seals. It goes to, there's a specification on it, and if I remember right, you can test up to 5 psi. It would typically be a plant test that you'd want to do, but it's something that's coming along and looks promising in the future. So I'd probably just leave it at that. But I think most of our applications don't always need a gasket either. So just have to
and I would
look
say
at it that
gasketed
way.
Boxes are not going to perform the same way a gasketed pipe does. Obviously, that round shape gives a really good seal. Where the box, we found sometimes those gaskets, obviously in the bottom, they can't be pulled around and equalized like they can in a pipe. So they are
it's
available.
A little different
I don't know that
process to glue them on, and but when we've done them, we've had good success with them. So.
Yeah. All right. Here's another one. How does the manufacturer incorporate lateral connections, and how should a connection be made if a box is already installed without a cutout hole?
We have had projects where they wanted like the boxes bolted together or connected, and we actually put pockets along the side where we could put bolts in and connect those together. Now, I think that was an FAA project. That would be pretty extreme to have to do. I've gone out and inspected these that are older, and they don't really move around or come apart after they've been. There's other things, like there are times when people have weld plates along the top. There are sometimes requirements to weld them together, but those have kind of gone out of the specs for the most part too. So there are some ways that way, but I think you need to look at the performance of these where they've been done well and installed well, and see what future performance you want. But where we've really done a good job with these, I think that's probably a little bit belt and suspenders to try and connect them together.
All right. Thanks, Randy. Someone was interested to see your picture, your pulling picture. So if you want, I'll send you that person's name to send it to after.
Okay.
Another question, are box culverts produced wet cast or semi-wet mix?
Okay, so we didn't get into dry cast versus wet cast. Smaller box culverts, it's probably going to be more typical to do those in dry cast. That's a zero slope concrete. And that's typically more economical because there's usually less labor involved than wet cast. When you get into larger box culverts, and just for just general knowledge, it's probably over the ASTM standards. It's probably something that's larger than a 12 by 12 but it depends on the manufacturer. When you start getting into those, we use a self-consolidating concrete. And I think a lot of manufacturers around the country are using that. And that doesn't require us to, in fact, you don't ever want to sting it or vibrate self-consolidating concrete. And it fills in quite well. So that's what we're typically using, but it depends. There may be reasons to do that on a smaller culvert on a certain job, or depending on scheduling or different things. So you shouldn't ever get prescriptive on the manufacturer of what they use. Both those will function the same way in a project.
And I would say, Randy, I know some manufacturers, they do all wet casting, small or large, and vice versa. So it really is dependent on your local manufacturer. Another thing on wet versus dry casting, we've had some agencies who do not allow dry casting for the purpose of freeze thaw because they want it air entrained. And there's been studies done that dry casting does not, I mean, you can put air entrainment in it, but you're going to vibrate all of that out. And the process of dry casting actually makes all of those large bubbles that you would get in wet cast and why you would air entrain. The dry cast vibration system actually makes all those bubbles very small and simulates an air entrained box. And so, or pipe for that matter. But
yeah,
you should.
Yeah, there's not a reason.
Box.
Exactly. There's not a reason to air entrain and dry cast because of the process, and those studies confirm that. So, dry cast, since I'm in Utah and we typically aren't very warm and haven't been all winter, freeze thaw has never been an issue that we've seen anything with here. So.
Okay, another question here.
We're at about 10:30, so why don't we take a couple more that are kind of maybe critical, and then the rest we could do online.
Okay.
If they...
Let me see here if there's some that are repeating. Is shifting of the sections a concern while backfilling? How important is it to backfill uniformly?
I haven't seen anything where that's been a huge issue, but you shouldn't put all your load on one side. These are pretty heavy and there's quite a bit of friction underneath there. So unless you're putting a huge load and really adding everything on one side, I think it'd be very difficult to push them around. But it's a good standard procedure to bring it up on both sides and to not put unequal loads on them and those kind of things. One more, Kim, maybe.
Yeah, so let me ask, I saw one come in that I get a lot of questions, not on this webinar, but similar, is can boxes be installed on a slope? And if so, is it on soil or rock? And then how would you affix it to the rock if it's on rock, or how do you keep it from sliding down the hill? I get that one a lot.
Well, you'd have to look at what that slope is. I know we had someone came in that had an end section that had a lot of pressure on it from a baffle wall. And there was a way to look at that, whether you put a cutoff wall on it to help it from sliding and pour that monolithically. But one of the things I think you have to be careful of when you're installing on a slope is you watched how the box culvert was hung from the crane. If you were on a slope, you would want to rig the crane so that box was coming in more on a slope. Otherwise, it would drag as it was coming into there. So you would want to install it with the slope. as far as anchoring it after, there's some ways you could tie those together and everything else, but you are going to get quite a bit of friction from concrete to gravel, and there is some calculations out there that you could do to check that. Whether you had issues, you would probably want to especially pay attention to the end section connection to the last box culverts. The only place I've ever seen problems is where they don't do cutoff walls or aprons or other things, and then they get scour on the ends. And so you probably want to really watch on that more than anything.
Yeah, thanks, Randy. A couple follow-up comments just to repeat. I've seen a couple of the questions still come in about whether this will be available. We are recording this, so not only will the recording be available, as long as Randy and Jason approve, we can also make the PowerPoint available to folks. And also the question was what others would like to see. I've seen that a couple times come through here. We again are going to send out a survey, so as soon as you close this webinar, it should pop up, which would you like to see next? If you don't see that, it's also going to go out in an email, so whichever is better for you, but we certainly would love to hear from you guys as to what would be most beneficial to listen to and do another webinar on. So with that, Randy and Jason, sure appreciate your time. Thank you everybody who's been on and still on, half hour past time. That's great to see such good interest in this topic. So we really appreciate it. Oh, last thing is I saw a PDH question a couple of times. I meant to mention that. We will be emailing out a PDH for anyone who was on the call. If you're in a group, feel free to pass that on to your group. We're working on an honor system there. And that will be a 1 PDH for this webinar. So again, thanks so much, and we'll look forward to seeing you again next time.
Thanks, everyone. Thanks, Jason.
Thank you. Appreciate it.